All right, we've been looking at balancing redox reactions or redox equations. You've seen the steps, you've seen two examples, example 3, and right here it says OH minus, so that's a clue that we want it to be basic. So we're going to put the chromiums together and balance. Don't forget we have two chromiums there, so we do the major, we balance the chromiums, then we balance the oxygens by adding 7 waters, and now we have to balance the hydrogens, 14 there, so we have 14 H pluses. Electrons, sometimes people find tricky. Over on the right, we have 2 times 3 is 6 plus there and 0, so the right side is 6 plus. The left side, 14 take away 2 is 12 plus. So we've got to bring the left side down from 12 down to 6. So we need 6 electrons on the left. Right now I'm not going to bother making it basic. I can always do that later in the redox equation. Now the other half reaction is going to be a little bizarre. We got OH minus becoming O2. So we do our steps, and that is we've got to balance out our oxygens. And once we've done that, now we'll balance out our hydrogens, usual way. And it's a little weird to have the OH minus become H plus, but we can deal with that. And we get an equation that looks like this. To make it basic overall, well, we had 2 H pluses on the right, so we're going to add 2 OH minuses on both sides. And that means those characters get together to make 2 waters. And 2 OH minus and 2 OH minus make 4 OH minus. So we now have our oxidation half reaction. So we have 6 electrons here and we have 4 electrons there. These are the 2 half reactions we care about. That's why they're in red. And 6 and 4 both fit into 12. That means we're going to have to double this half reaction and triple this half reaction. So there's our doubling. And there's our tripling. That'll get us up to 12 electrons for both, and then we can ignore the electrons. So we got to go 2 times all these things, multiplying by coefficients, and 3 multiplying by all the coefficients. So there we are. We've doubled everything. The 2, the 28, 12. We kept them in there, but we'll get rid of them in a moment. And we've done the same thing over here. So now we are ready to combine these two things. That means tallying up all our reactants to become all our products. And we end up with this long chain here. Boom, 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 boom. At this point, we could double check things are balanced. Now, what we also see is we have 28 H pluses and 12 OH minuses. So overall, 12 of those H pluses are going to get together to make waters. So there's our 12 water, and that left behind 16 H pluses. And we still had the 12, and here I had 14 and 6, and that's why it's 20 waters there. So more simplifying to do. The H pluses are all good now, but we had 12 there and 20 there. So that's going to boil down to 8 waters on the right. Now, this is a balanced redox equation, except it's in acid right now. We got our 4 chromiums, 4 chromiums. We got 14 oxygens there, 8 and 6 is 14, 16 H's and 16 H's. And we can see that our charges are working out quite nicely as well. Because here we had 2 times 2 minus is 4 minus 16, so that side's 12, and 4 times 3 is 12. To get it to be basic, we've got to add 16 OH minuses here and 16 OH minuses on that side. So that's what we've added, boom and boom. Flips it to base. We know this is going to come together and make 16 waters. So that's where that comes from. There's our 16 waters. And we've included our 16 OH minuses. 16 waters on the left, 8 waters on the right. That means we end up with a net of 8 waters on the left. And that is our final reaction. So you can see these things are large questions. They're not difficult as long as you take your time and do correct steps each time. We have 2 times 2 is 4 chromiums. 2 times 7 is 14. 14 and 8 is 22 oxygens left. Here we have 6 oxygens, 16, 22 oxygens on the right. 8 times 2 is 16, 16, so hydrogens are balanced. And we can see we have 4 minus on the left. And here we have 4 times 3 is 12, 12 take away 16, and again we have minus 4 on the right. So everything is checking out, so that should be a proper balanced redox equation. There's a lot going on, and I've done some complex examples to make sure you're ready for the worksheets that are coming up. So you have 3 really good examples now to look at if you're getting confused. Make sure you copy things carefully. If you're copying from a phone, I don't know how you see the charges. Hopefully you have a bigger screen somewhere. All the best. We will carry on.